Hey everyone, welcome back to the channel, and today we will be starting off with trees from our SD sheet. So I'll just quickly show you the problem statement. So we are done with our linked list. Now we are starting off with binary tree. The problem is height of a binary tree. Let me just check if we are live. Should be. Yes, we are. From just mute. Fine. Okay, let us start off. So fine, what you have to do here is you are given a binary tree and you have to find a height. How do we do that? Let's see. I'll explain it to you. Simple and basic problem, but very important for better problems based on trees and all. Okay, I'll just set this up. Okay. So first of all, it's a binary tree. So let me draw any tree, 10, 20. Let's say 30, 40, 50. What is the height of a binary tree? So the maximum depth of a tree starting from the root node to the deepest level node. What is the deepest level node? 40, 50 both lie at the same level. So the number of how many nodes do you find from starting from root? If you, for example, if you consider it as level 0, right? So see in what way they are expecting you to return the answer. When you got a tree like this, you are returning 2. When you got a tree like this, you are returning 3. So basically, the number of nodes starting from the root, not nodes, number of levels starting from root till the last level of your node, right? Deepest level of your tree is the height of your binary tree, right? So we are starting from here. This is level 1, second in terms of height, and third. So basically you will be returning 3 for such a case. Okay, for example, if I have 10, 20, 30. Cool. So starting from the root node, what is the deepest level node? 30. So from here, how many levels are there? 1, 2 and 3 levels are there. So again the height is going to be 3, right? How can we do that? So you will see lots of application of recursion in binary trees. So that's what we are going to use here. We will be using recursive way. There are other methods also. Let's discuss an approach. We start from root level node. Okay, now what do you think? You have a function which is expecting you to return an int value, right? Int type value. That's the height of the tree. So for example, this is your height function. Okay, this is your height function, and node root has been passed. Now what you are trying to do here is that we'll write the base case condition. What would be our base case condition? So basically we are trying to go through each level. But for example, if my tree was in such a way that after 50 it was 60, then probably, okay, for example, if this was my case, so you'll see that the deepest level node is 60. And from here, how many levels are there? 1, 2, 3, 4 levels. So your height will be 4, right? That clearly means that in order to find the height, in order to find the deepest node, you will have to traverse through all the nodes of a tree. As in, for a particular node, you will have to explore its left side also and its right side also. So while exploring, when you reach the null node, okay, you will simultaneously be calculating the height or level or whatsoever, right? So once you reach the null node, right, from there you return the height of what you have explored so far. The only thing that you will be doing is you'll compare that what left subtree gave you a height, what right subtree gave you height, store the maximum of those, right, and keep traversing like this, explore all the nodes. Let's see in terms of code how are we going to do it. So what check are you going to put? Our base case condition will be if our root is null, right? If for example there is no root, there's no, then obviously level is going to be, the height of the tree is going to be 0. You return 0. Okay, then I take two variables. Let's take int left height, which will be storing the left height so far that I have explored by traversing through all the left nodes of the tree. Then I make a call to height by passing root dot left. Okay, same thing I'll explore for right side. let's store a variable right height, and I will make a call to the same function which will be exploring right side of the tree, right? I'll show you the dry run how recursion is working here. Now once we have the left height and the right height, my target is to check which one is greater of the two. If in case my left height is greater than my right height, what should you return? I'll show you. I'll keep this blank. First I'll show you the dry run, then we will fill up that blank. Okay, let's take an example of this tree itself. I have 10, 20, 30, okay, 40, let's say 50 and 60. For example, this is my tree. Okay, in my recursion, this is the recursion stack that I am making here. For example, initially I made a call to height passing this 10, right? I passed 10 here, so obviously it's not null. You go to the left height, you make a call to the left of this 10, you make a call to height function again by passing 20 there. Okay, and it will have its own left height which will store answer later on, which we will return from here. We'll see what is going to happen. Again, you make a call to this function for when your root is 20. Now again 20 is not null, you go and explore its left side, so you again end up making call to this height function. H is representing height function, okay, h of which node? 40, right? And its next will be null. Fine. So when I make a call to root 40, is it null? No. So you go to the next line of code. Again, in your left height, you through your left height variable, you're making a call to the function again for the left of this 40, so which is null. So when I end up making a call to null, I hit the base case condition. So now the root is null, right? Now the root is null, so I return 0. This 0 will be returned to this function, basically to the left height of what? Left height of the function which made a call to this height by passing null into that as a root, right? So its left height has gotten its answer as 0. Fine. So since this got its answer as 0, I'll move to the next line of code, and first of all I'll remove it from the stack. Why? Because it has gotten its answer. But wait, actually not yet. Before that, also I have to make a call to the right side of this 40, because through this line I will make a call to the right of 40, which is null again. So that will be null. So right height, I'm not writing it here. Again, h null will be called. Right height will get its answer, which is 0. So here I have to make a decision. I'll check which one will be greater. For example, if left height had given me an answer of 1, for example, what would you choose? Would you choose 0 in that case? No. Why? Because I want to explore the deepest node. That is how I'm going to get the height of my tree, right? So the one which will be giving me the maximum height, I will take that up. So if my left height is greater than right height, what am I going to do? See, so I have to prepare my answer for this. We will see. I'll return left height plus 1. Now why plus 1? You'll just wait, I'll show you. In the else case, now you understood, if right height is greater, I'll return right height plus 1. Why plus 1? Wait, after a few more dry runs you will understand. Okay, so it got its answer. Now wait, I got left height and right height 0 for 40. So 40 is going to return maximum of left and right height, which is going to be 0 for this. Okay, now 40 gets removed and it gives its own answer for left height as 0 plus 1 to 20, right? So since both were equal, in the else, I go to else case and give 0 plus 1 as my answer. Now this 0 plus 1, that means 1 will be returned to 20. This 20 must have made a call to its left height, right? So that left height was h of 40. So it has produced its answer and has returned left height as equal to 1 to 20. Now wait, I have gotten left height equal to 1. I'll go to the next line of code, which was, if you think recursively, we are now coming back recursively. So while I come back, I see I have to make a call to height function again, and that will be for right height, correct? I make a call again. Now this will be making call to right of your 20. This will make a call to height with root as 50, right? Okay, now what is root equal to null? No. Now I'll make a call for left height for 50, which is null. So it will return it's a null. So what will you get? You'll get nothing from there. Okay, you come back, you make a call to the right side of 50, you make a call to 60 here, right? Then again, both of them are null, left and right of 60 will be null, so it will have its answer as 0. Now wait. So see, 50 has gotten an answer of 0 from left side, but when I talk about 60, okay, root is null, you return 0, 60 explores its left and right. When it comes out, when it gets removed from the top of your stack, that means you have explored all the left and right for 60. Now you return your answer to 50, and its right height, the right height of 50 is going to be 1, correct? So this is going to be 1. What you return to 50 is going to be 1. Clear? 50 has got, it has given its own answer, which is equal to 1. Okay, now 50 including itself will return its answer as 2, correct? So you have to, this plus 1 is for the root node itself, for which we are producing the answers from left height and right height. Got it? Okay, once 50 gets removed, now the task of this function call should have gotten its answer from left and right height, which is the maximum of 2. So basically it is from 50, from right of 2 I'm getting answer as 2, total answer is 2, and from left of 20 I'm getting 1. Maximum is 2, so 2 plus 1 is 3, so it has produced its answer as 3 so far. So it returns 3 to 10. Okay, so fine. Now 10 will explore its right side, 30 will eventually end up giving its answer as 1, correct? So 10 has option to check left and right height which is greater. Obviously 3 is greater, so it will return finally 4, and this 4 will be returned to the main function call which we made from the main function, you can say. So 3 plus 1, 4 will be returned from root node, and that is the end of all the recursive calls that we made. Okay, so I just went through this entire dry run so that you can understand recursion also, that how it is taking place on this tree. Otherwise the code is very simple, okay, but you need to understand how calls are taking place, why we are adding 1 here. This one is we have added because left side has given its answer, right side has given its answer. Now you have to calculate which one is greater, but this is the stage where you have to produce your own answer, so you'll include yourself. This is the reason 1 has been added, because see, 10 got its answer as 3 from left side, 1 from right side. So finally it chooses 3 because that is the maximum depth it has gotten after 10, right? So it has to include itself, so the final answer is 3 plus 1, 4. This is the height, 1 2 3 4, right? So that is all about this problem. Also talking about time complexity, as you can see, although the recursion calls are being made, but you can see at max we are on exploring every node at max only once. When we saw this recursive stack, how the calls were made, you could see that we have made call to each and every node of this tree. So max, the time complexity is big O of n, and obviously for this recursive stack we always have this recursive stack for recursion, so O(n) of space complexity for this recursive stack. That's all. Okay, for recursive stack. So let's code it so that you can understand. I'll just check if yes, Sriram, so you are returning math.max. That is absolutely correct. We can exactly do it in one line also. Just for the explanatory purpose, we are starting off with binary trees. Today is the first lecture. That is why I've written it a little elaborately, but what you have written is absolutely correct. Okay, so I'm starting off with if node is equal to null. That means there is no node, there is no level, return 0. Then what you are doing, int left height equal to, making a call to height function root dot left. You're making a call to right to height function for the right side root dot and then you make a decision. As you said, we can write it in one line also, but okay, I'll write it. If left height is greater than right height, return left height plus 1, else you return right height plus 1. Fine. This is going to be node. Node, let's see. So that's all about this problem, everyone. If you have any doubts, you can ask me. Otherwise, we are done with this question. Okay. So if there are no doubts, I'll just wrap it up. Fine, everyone. Then that was all for today. See you all in the next lecture, that is tomorrow. Thank you and take care.